Hi everybody, this is lesson 94 on page 640. This lesson is about compound probability. If you recall, when we talk about probability, we are talking about the outcome that you want to get over all possible outcomes. And in the first part of the lesson, it uses an example of a coin to make this point. If you have a coin, a standard penny or any coin, typically it has a head side and a tail side. And if you toss that coin one time, we know that the possibility of getting heads is 1/2 because there's a 50-50 chance of getting heads or tails. We can write this by this, P times H equals 1/2, which means probability of getting heads is 1/2. You have a 1 in 2 chance of getting heads. The outcome you want, heads, over the possible outcomes, heads or tails. Okay, we can also diagram this by using what's called a tree diagram, and these are kind of fun to draw and to map out to figure out all of these. We can do that by, if we took one coin and we toss that coin, you could either get heads or you could get tails. So there's your very simple basic tree. Now, what if we toss the coin a second time? Let's say we tossed the coin the first time and we got heads. We tossed it a second time and there's two possible outcomes. Again, we could either get heads again or we could get tails this time. On the other hand, if we tossed it and you got tails the first time, if you tossed it the second time on that round, then you have another possible outcome of getting heads again, or you could get tails again. So this is your first roll. Let's put first right there. Your first roll, and this would be if you had a second. So this is, so basically from this diagram we have four possible outcomes. If you if you flip a coin twice, you could either get heads, we're going to do HH for that. You could get heads then tails. You could get tails then heads, or you can get tails and tails again. And these four possible outcomes are called a sample space. Since any of the four possible outcomes in the sample space are equally likely, the probability of each outcome is 1/4. So in other words, you have 1/4 of a chance of getting any of these outcomes. You have a 1/4 of a chance of rolling a dice twice and getting heads and heads again. You have a 1/4 of rolling it twice and getting heads and then tails. You have a 1/4 of a chance of rolling it and getting tails, then heads, and you have a 1/4 of a chance of rolling it twice in a row and getting tails. So this outcome would be 1/4 because you have a 1/4 of a chance of getting any of those possible outcomes. When the outcome of one event does not affect the probability of a second event, the events are called independent. Each coin toss is an independent event because the outcome of one toss does not affect the outcome of the subsequent toss. Meaning, if tossing heads does not affect whether or not you're going to get heads or tails, because you still have a 50-50 chance after that. Tossing tails the first time doesn't affect your second toss, so they're independent. The key to remember with this lesson is the probability of independent events occurring in a specific order is the product of the probabilities of each event. Okay, we're going to go ahead and look at example 1. Basically, these problems just require thinking things out, using practical thinking, visualizing things, and remembering that probability means the outcome you want over all possible outcomes. So let's go ahead and look at example 1. Okay, in example 1 on page 641, it says the face of this spinner is divided into 4 congruent sectors, basically meaning equally divided into 4 spaces. What is the probability of getting a 2 on the first spin and a 1 on the second spin? Alright, so if you wanted to get a 2 on the first spin, that means there's only one section that has a 2. That means there's one chance of getting the outcome that we want. And there are 4 possible outcomes. So you have a 1/4 of a chance of spinning a 2 on the first spin. Now, they said in a 1 on the second spin. So if you got lucky and you actually spun a 2, and then you spin again, what's the chance of getting a 1 on the second spin? Well, there's only one up there, so you have a one possible outcome that you want on that second spin, and there's still 4 possibilities, so you have 1/4 again of getting that. So the possible outcome these would be multiplied together. So you have a 1/4 of a chance of getting a 2 on the first spin. you have a fourth of a chance of getting a 1 on the second spin. So what's the probability of it happening in that order, of getting a 2 and then getting a 1? Well, basically you multiply those together and you have a 1 in 16 chance of getting 2 and then a 1 in that order on your first and your second spin. So those just require some thinking through to figure those out. But the key to remember is your first spin multiplied by your second spin. If you had other spins after that, it would be the same thing, multiplying those probabilities to find out what your end result is. Okay, let's look at the next example. All right, in example 2, it says Jim tossed a coin once and it turned up heads. So he got heads on the first toss, no question about it. What's the probability that he will get heads on the next toss of the coin? So after he tosses heads once, he tosses it again, and he has a chance of either getting heads or tails. So the chance of getting heads on the second toss, in this case, would actually just be 1/2, because you have a 1 and 2. There's one outcome you want, 2 possible outcomes that you want. So you would have a 1/2 of a chance. And on this one, you're probably thinking, now wait a minute, it said he tossed it twice. But they told us already the outcome of the first toss was definitely heads. So there's no unknown there. That is known. They only asked for the probability on his second toss, which is unknown. So this is the probability for the second toss, since we already know what the first toss is. So that's how example number 2. You have to watch the wording of these and kind of map out what they are actually asking for to understand these. So let's look at the next example. All right, example 3 involves a chart that is much better drawn in your book on page 642, but I have drawn the basic diagram here on the board. The problem says in example 3, if a pair of dice is tossed once, what's the probability that the total number rolled will be 12? Well, if you think about it, on a dice set, of course, it has 6 sides, 1 through 6, and you have 2 of them. What's the chances of rolling a 12? Well, you have to have 2 specific numbers. You have to roll a 6 and then another 6 to get to a 12, because 6 plus 6 is 12. No other combination of rolls will get you a 12. So what's the chance of rolling a 6 on the first dice? You have 1 out of 6. What's the chance of rolling a 6 on the second dice? 1 out of 6. And you multiply those together and you get 1 out of 36. This is also shown, if you look at the board here, there's only one 12, because we know 12 would only come from 6 and 6. So you have a 1, and there's 36 possible outcomes if you counted all these numbers. So 1 out of 36 could equal 12. That's how you do example 3. For example 4, I'm going to go ahead and leave this up here. For example 4, we're going to use this as well. And example 4 says, with one toss of a pair of dice, what's the probability of rolling a total greater than 9? All right, so think about this. So greater than 9 means not 9, but anything higher than 9. And that basically is this little section right here. So let's look at this. There's 2 different ways to figure these out, and I'll show you both. So this, we know that there's a total of 36 possible outcomes. So I'm going to put in 36 because that's our total possible outcomes. But the outcome we want is greater than 9. So how many choices are there? There's 3 10s, 2 11s, and a 12. So how many numbers? 1, 2, 3, 4, 5, 6. 6 out of a 36 chance. You can reduce that, which would be 1 out of 6. So you have a 1 in 6 chance of rolling a number greater than 9 when you have a pair of dice. Now, the second way we figure that out, and of course it will get the same answer, the second way of figuring that out is think about the combinations that get you to these. Okay, what number combinations get you a 10? We could have a 6 and a 4. So a 6 and a 4, we could have here we could have a 5 and a 5, and then we can have a 4 and a 6. There's 3 possible ways to get a 10. So we could say 3 out of 36. 3 out of 36 will get you a 10. Then you can say, okay, well, how about 11s? We can do a 6 and a 5, or 5 and a 6. 2 out of the 36 will get you an 11. And then, of course, we already learned that a 12, there's only one chance of getting a 12, so 1 out of 36. You add all those together, 3 plus 2 plus 1, and you still get 6 out of 36, which reduces to 1/6. So you get the same thing. All right, when the outcome of one event affects the probability of a subsequent event. The events are dependents. So the key to remember there is the probability of dependent events occurring in a specified order is the product of the first event and the recalculated probabilities of each subsequent event. All right, let's go ahead and look at the next example. Okay, on page 644, we see example 5, and it says, from a well-mixed deck of cards, Josephina selected and kept one card, then a second card, then a third card, and finally a fourth card. What is the probability that the 4 cards Josephina selected are aces? Okay, so the first thing we need to keep in mind is a standard deck of cards has 52. There are 13 hearts, there are 13 diamonds, there are 13 spades, if I could draw a spade, and there are 13 clubs in a standard deck, okay? And each one is ace, no ones, ace, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and then jack, queen, and king. Okay, those are the 13 in each of the different suits. All right, so let's look at this again. So total of 52 altogether. So if the deck is well mixed, she picks one card. Each of these is going to have an ace. There's ace of hearts, ace of diamonds, ace of spades, and ace of clubs. So that means there are 4 aces in the deck at this point. And there are 52 cards altogether. So what's the chance of her drawing an ace on the first one? Well, that reduces to 1 over 13. She has a 1 in 13 chance of getting it on the first one. Okay, so here's how we're going to do this. We are going to, before we do this simplifying, I'm going to show you something that's quite interesting. Before we get to this part, we're going to stick with the not reducing yet. I'm going to write this down right here and leave that right there because we'll get to the simplifying in just a little bit. Now, that means she pulled another deck for the second time. Now, the first time she pulled a card out, there were 52 cards. Now that she has pulled a card out, there are only 51 cards left in the deck. So if she pulls a card out, so the number, let's say she got lucky and she actually did pull an ace out the first time. Now her chance of getting an ace on the second pull is only 3. She has a 3 in 51 chance of getting a ace on the second pull. So she goes for the third pull. Now there's 1 less out of the deck because she's already pulled 2. Now there's only 50 cards in the deck. Let's say she happened to get an ace on the first and the second. Now she only has a 2 out of 50 chance of drawing an ace on that third pull. And again for the fourth, we go down in 1 more number. Now there's only 49 cards, and let's say she happened to get 3 aces on there the first 3. That means there's only 1 ace left. So to figure out her probability, we are actually going to multiply these all together to get our answer. And you're thinking, wow, those are some pretty big numbers, but we can reduce. And here's where the reducing comes into play. We know that 4 in 52 can be reduced to 1 in 13. 3 in 51 can be reduced to 1 and 17. And 2/50ths can be reduced to 1 and 25. Unfortunately, 1 over 49 does not reduce. But the good news is you have all ones on top, so it's going to be 1 out of something. If you take the time to multiply all these numbers out, and if you get it correctly, you would get 270,725. So she has a 1 in 270,725 chance of pulling all the 4 aces out on the first 4 pulls. So that is a good lesson in statistics with that one. So these again just require a lot of thinking things out, basic thinking, visualize what you're reading, and putting the pieces together. So if you have any questions, let me know.